Calculate the size of a cylindrical riser, height and diameter equal, necessary to feed a steel slab casting of dimensions 25 into 25 into 5 centimeters with a side riser. Okay. Casting poured horizontally into the mold. For steel, the values of constants A, B and C are given as 0.10, 0.03 and 1.00. So here we have to design a cylindrical riser, and here height and diameter equal. So height and diameter of cylindrical riser are equal, and here there is a steel slab casting of dimensions 25 into 25 into 5 centimeters is given. So here type of riser is side riser. Here we are using side riser, and here casting poured horizontally into the mold, and for the steel given values of ABC. So here we have to design a cylindrical riser. There are 4 methods in general, most popular methods. There are 4 methods of riser design. So methods of riser design, methods of riser design. Let us discuss methods of riser design. So what are the methods of riser design? The first method, Keynes method. First method, Keynes method, and the second one, modulus method. Keynes method, and the second method, modulus method, and third method, novel research method. Novel research method. I think we have one more method. So method number 4. So one more method, shrinkage volume method. Shrinkage volume method. Okay. Shrinkage volume method. So there are 4 methods to design a cylindrical riser. Here main question is which method we should select. Which method we should select. So ఏ మెథడ్ సెలెక్ట్ చేయాలి ఈ క్వశ్చన్ కి, ఈ పర్టికులర్ క్వశ్చన్ కి ఏ మెథడ్ సెలెక్ట్ చేయాలి? ఓకే, సో ఫస్ట్ ఆఫ్ ఆల్ let us list out given data. Based on given data we should select type of method, whether we choose Keynes method, modulus method, novel research method or shrinkage volume method. సో ఏ మెథడ్ యూజ్ చేసి డిజైన్ చేయాలో అనేది ఎలా తెలుస్తుంది మనకి? బేస్డ్ ఆన్ గివెన్ డేటా, బేస్డ్ ఆన్ క్వశ్చన్. సో ఇన్ దిస్ క్వశ్చన్ ఈ గివెన్ dimensions of casting. Dimensions of casting. Dimensions of casting. So dimensions of casting what? 25 into 25 into 5 centimeters. Okay. Next. Dimensions of riser. Next. Dimensions or for riser. For riser. Diameter is equal to height. For cylindrical riser, diameter is equal to height. So D is equal to H. Here D is equal to H. Diameter of riser is equal to height of the cylindrical riser. Okay na? So D is equal to H, and at the same time very important information. He given constant, some constant A, B, C. So here material is steel. Here we are using steel material. For steel he given some constants A, B, C. Okay. So A value how much? 0.10 and B value 0.03 and 1.00 C0. See the here A, B, C are the constants. We observe A, B, C in Keynes method. In Keynes formula we observe A, B, C. We have parameters A, B, C, constants. So A, B, C అనేవి ఎక్కడ ఉంటాయి మనకి? Keynes method formulas లో ఉంటాయి. So based on A, B, C, based on given constants, we should apply Keynes method. To solve this problem we should apply Keynes method. Okay na? Because he given A, B, C constant values. A 0.10, B 0.03, C 1.00. So we should select Keynes method. Now let us solve this problem using Keynes method. Okay. So Keynes method. Keynes method of riser design. So in Keynes method we have two formulas. The first formula is freezing ratio denoted by capital X. Freezing ratio is equal to surface area by volume of casting whole divided by surface area by volume of riser. This is formula number 1. And freezing ratio is also taken as freezing ratio X is equal to second formula small a by capital Y minus B plus C, small c. Okay. Where Y is called volume ratio. So volume ratio is equal to volume of riser by volume of casting. So we have two formulas for freezing ratio. So freezing ratio X is equals to surface area by volume of casting whole divided by surface area by volume of riser. And also freezing ratio X is equals to A by Y minus B plus C. So using freezing ratio formulas we can design cylindrical riser. So first of all let us find freezing ratio X. So for casting, so given dimensions 25 into 25 into 5 centimeters. So based on dimensions we can say that it's a cuboidal casting. Shape of casting is cuboidal. Okay. So in case of cuboidal casting, surface area of casting is equal to what? Surface area of a cuboidal shape. Surface area is equal to 2 into length, breadth, height. Okay, now L into B into H. So LB, surface area of casting, cuboidal casting formula, 2 into LB plus BH plus HL. LB plus BH plus HL. Now, so substitute all values. 2 into L. So length of the casting 25 centimeters into breadth 25 plus BH 25 into height 5 centimeters plus height 5 into 25. So if you simplify this, 2 into 25, 25s are 625 plus 25 5s are 125 plus 125. 125 plus 125 250 plus 620 625. 250 plus 875. So you will get 2 into 875 1750 units surface area centimeter square. Next, let us find next we need volume of casting. Now volume of casting is equal to what? Volume of casting. So volume of cuboid LBH, length into breadth into height. So 25 centimeters into 25 centimeters into 5 centimeters. So you will get 625 into 25 625 625 into 5 3125 centimeter into centimeter cube. So this is volume of casting. So here we are going to find the freezing ratio. Okay. So to get freezing ratio, we need surface area ratio of surface area and volume of casting and ratio of surface area and volume of riser. At last, say these two are see, this first we have freezing ratio is equal to this formula, and second formula freezing ratio is equal to this formula. So these two are equal. Okay, both are freezing ratios. So by equating equation 1 and equation 2, we can find diameter of cylindrical riser. So దీని నుంచి రెండు two formulas యూజ్ చేసుకొని diameter of cylindrical riser find out చేస్తాను final గా. Okay. First, next let us find surface area to volume. I mean surface area and volume of riser. For riser, so we have to find the surface area of riser and volume of riser. So here shape of riser is cylindrical. So we are designing cylindrical riser. See. So this is cylindrical riser. So in this question he given diameter of riser is equal to height of the riser. Diameter of the riser is equal to height of the riser. D is equal to H. Okay, now it's clearly given in the question. So diameter is equal to height of the riser, and first of all let us find surface area of riser. Surface area of riser. So surface area of riser. So surface area of riser is equal to, so this is cylinder. So surface area of cylinder is equal to lateral surface area plus. So in general we consider two times of area of each base. See, this is lateral surface area of cylinder, and still we have top and bottom. Okay, na top and bottom, nothing but two bases. We have two bases. So while finding surface area of riser, we always consider area of single base, only one base, because one base is open to atmosphere. Okay, na? So this is hollow. So one base is open to atmosphere. One of the base is open to atmosphere. So this is closed. So we only consider area of base, one base. Okay, na? We do not consider area of two bases. We consider area of one single base. Okay, na? So other base is open to atmosphere. Okay, na? Top face is open to atmosphere. Okay, na? So anyhow, lateral surface area of cylinder is what? Pi d h plus area of base. So base of cylinder is circle. Area of circle formula pi by 4 into d square. Okay, na? So cylinder ki, cylindrical riser ki మనం ఎప్పుడైనా ఏరియా సర్ఫేస్ ఏరియా ఫైండ్ అవుట్ చేస్తే రైజర్ కి ఓన్లీ లాటరల్ సర్ఫేస్ ఏరియా ప్లస్ ఏరియా ఆఫ్ బేస్ తీసుకుంటాం మనం. ఓకేనా? సో జనరల్ గా సిలిండర్ కి అయితే మన ఫార్ములా ఎలా రాస్తాము? ఇన్ జనరల్ అయితే మనం చేసేది లాటరల్ సర్ఫేస్ ఏరియా ప్లస్ 2 ఇంటూ ఏరియా ఆఫ్ ఈచ్ బేస్ తీసుకోవాలి. బట్ ఇక్కడ ఏంటంటే వన్ ఆఫ్ ద బేస్ ఈజ్ ఓపెన్ టు అట్మాస్ఫియర్. ఓకేనా? అది ఓపెన్ అయ్యి ఉంటుంది. సో మనం అది కన్సిడర్ చేయము. పై d into, here we know that d is equal to h. In place of which we can take d. So d into d square plus pi by 4 into d square. Now see, look at first term and second term. Pi d square is common. Pi d square common. Here we have 1 plus here 1 by 4. 1 plus 1 by 4. 4 ones are 4 and 4 plus 1 5. So 5 pi d square by 4. Next, this is surface area of riser. Next, volume of riser. So volume of riser, volume of cylinder formula. What is the formula? Pi by 4 into d square into h. So pi by 4 into d square. H is equal to, again h is equal to d. So you will get pi d cube by 4. This is volume of cylindrical riser. Next, let us find freezing ratio. Okay. We know that freezing ratio x is equals to surface area by volume of casting by surface area by volume of riser. Now surface area of casting. Surface area of casting how much? 1750 by volume of riser. Sorry, volume of casting 3125 centimeter cube. Okay, by surface area of riser. Surface area of riser 5 pi d square by 4 by volume of riser pi by 4 into d cube. Okay na? So pi by 4 get cancelled, d square and 1 d square get cancelled, still we have 1 d here. So 1750 by 3125 by 5 by d, 5 by d. X is equal to, take reciprocal, 1750 by 3125 into reciprocal of 5 by d, d by 5, d by 5. So x is equals to, if you calculate this value 1750 by 3125, you will get 0.56. So 0.56 into d by 5. 0.56 by 5. If you calculate again, you will get 0.112 into d. This is freezing ratio, expression for equation of freezing ratio. So let it be equation number 1. Let us consider x is equal to 0.112d is equation number 1. Next, we have one more formula for freezing ratio. X is equals to a by capital Y minus b plus c. We already given values of a, b, c, and let us find y first of all. So y is equal to what? Y is equal to volume of riser by volume of casting. Volume of riser by volume of casting. Volume of riser pi by 4 into d cube by volume of casting 3125. Now y is equals to pi d cube by 4 into 3125. So if you calculate pi by 4 into 3125, you will get approximately 2.513 into 10 to the power of minus 4 d cube. So this is volume ratio. Now put y is equal to 2.513 into 10 to the power of minus 4 d cube in freezing ratio. So x is equals to a value. A, B, C are constant. A, B, C already given in the question. So how much? A given 0.1 by y value 2.513 into 10 to the power of minus 3 d cube minus b value 0.03 given plus c value 1. Equation number 2. Now in both the equations, what is the unknown? Unknown is d. What is d here? Here d is equal to diameter of riser. Ultimately we have to find diameter of riser. So diameter of riser is equal to height of the riser. Remember, it's diameter of the riser is equal to height of the riser. So to find diameter of the riser, equate. See, here LHS are equal, same. Okay, now both are formulas for freezing ratio. So equate equation 1 and equation 2. Now we equate equation 1 and equation 2. So equate 1 and 2. So x common. Now equate, now equate RHS. So you will get 0.112d is equal to 0.1 by 2.513 into 10 to the power of minus 4, not 3. 10 to the power of minus 4. 10 to the power of minus 4. 10 to the power of minus 4 d cube minus 0.03 plus 1. By solving this equation, we can find diameter of the riser. Now transpose plus 1. So 0.112d, my positive 1 becomes minus 1. Okay. Next 0.1 divided by 2.513 into 10 to the power of minus 4 d cube minus 0.03. Okay. Now transpose denominator. Division becomes multiplication. You will get 0.112d minus 1 into 2.513 into 10 to the power of minus 4 d cube minus 0.03 is equal to 0.1. Next. Now apply distributive property. So 0.112d into this. You will get approximately, here I got approximately equal to 0.28 into 10 to the power of minus 4 d power 4. Now 0.112d into this. So if you multiply, you will get approximately minus, here I got minus 3.36 into 10 to the power of minus 3 d. Okay, this into this. Next, minus 1 into this one. You will get minus 2.513 into 10 to the power of minus 4 d cube. Minus 1 into minus 0.0 plus 0.03 is equal to 0.1. Is equal to 0.1. Now transpose 0.1 to right hand side. So 0.28 into 10 to the power of minus 4 d power 4. Next d cube term. Minus 2.513 into 10 to the power of minus 4 d cube. Next d term. Minus 3.36 into 10 to the power of minus 3 d. And plus 0.03 transpose 0.01. You will get minus 0.1. So 0.03 minus 0.1, how much? 0.03 minus 0.1. Minus, how much we get? 0.07 is equal to 0. Is equal to 0. So this is biquadratic, biquadratic equation. Okay, now what is biquadratic equation? Okay, now an equation of order 4 is called biquadratic equation. See, in case of biquadratic equation, highest power of the variable is 4. See, here variable is d, here d is our variable, unknown. So highest power of d is 4. So this is biquadratic equation. By solving this equation, by solving biquadratic equation, we get d. We get d. So using scientific calculator, we can find solution of this biquadratic equation. Okay, now here I got 4 solutions. Let me write 4 solutions here. I got 4 solutions. So my solutions are, so first solution, d approximately equal to, since it's a biquadratic equation, here highest power of the variable is 4. Okay, now order is 4. We get 4 solutions. So ikkada degree entunte manaku anni solutions vastayi. Here degree of biquadratic equation is 4. So we get 4 solutions. First solution, d approximately equal to, approximate values, minus 5.144. Next, d approximately equal to 11.517 centimeters. Next, d approximately equal to 1.2870 minus 6.3859 I centimeters. Next, 1.2870 plus 6.3859 I. See, last 2 solutions are complex solutions. These 2 are complex numbers or imaginary numbers. Okay, so first, so now we have 4 solutions. Among 4 solutions, only valid answer is 11.517 centimeters. D approximately equal to 11.517 centimeters. And what about remaining 3 solutions? See, here d is diameter. What is d? D means diameter of cylindrical riser. So diameter cannot be negative. It is always positive quantity. It cannot be negative. So minus 5.114 centimeters is not our solution. Okay, this is wrong solution. Next, so d approximately equal to 11.517 centimeters. This is diameter of the cylindrical riser. This is my answer. And what about last 2 solutions? These 2 are complex numbers. Okay, now they cannot be our solutions. Okay. So therefore, what is the diameter of cylindrical riser? 11.517 centimeters. Okay, now diameter or height, because diameter is equal to height. So this is the final answer.